break.
Discs. What?
Yes.
Water.
It's embarrassing. I know. You should try to
I Look what I made in chemistry class.
What is it? Looks like
Tie-dye t-shirt.
looks like blood.
No, it's tie-dye.
Oh gosh. I have PTSD from that.
Really?
Yeah.
What happened? Last time you
Tie-dye.
fight?
No, my wife went through like a month where she tie-dyed and bleached like, I don't know, 50 shirts or something. I was just like, you have too many already. Like,
Yeah.
stop doing that.
Well, you know, it's kind of like the possibilities are endless when it comes to tie-dye.
I think there are
Yeah, but how often do you-
You serious?
Yeah, it's just
Well, it's the same
Color it and
spiral.
shape.
It's, well, you can actually do it different than the spiral.
I know you can do it different in the style, but
I didn't know that.
there comes a point where the tie-dye is no longer unique.
Maybe.
It's not
You could do
endless
different
combination.
colors or something.
Yeah, you just gotta.
How many colors are there?
A lot, let me tell you.
Yeah, so you're gonna tell the difference between cerulean and cyan on a tie-dye?
Well, I guess yeah, it's good. Yeah, I like cerulean personally.
I could not. It's
Uh-oh.
only had to run some miles.
I don't think I'll be together again.
I don't know what happened here. You got any big plans for spring break?
No, just do some house chores.
Is it just this one we're turning in?
Yep.
Unless you turned it in Google Classroom. I don't need both.
Or when is the, what's the other one that we did? Is that one even, or you turning one of the 3D cross sections? Yeah. When's that due?
This one?
Yeah.
I'm gonna ask that you work on it more after this stuff today.
Oh, okay.
So I will ask for it after break.
Got it.
But I'm not gonna give you. After today, there won't be more class time.
I
for it.
finished 102, right? That's all there is this stuff.
No, you actually have to work with that.
Oh, work them out.
But don't worry about that till later.
Is number 101 the last assignment due before spring break? The circuit? The
No.
circuit training?
I'm doing the Khan Academy grade today.
Oh,
Why?
is it Khan Academy?
I have it typed up for
my
you.
bad.
Alright. Now they're late.
Shut up. They're not late yet.
You can't tell me to shut up.
Sorry, I'm sorry. You know, I take my homework grades very seriously because I put you on a lot of time and effort.
One question is,
I'm sorry to have it. I wasn't forgetting.
Yeah. You said that last class too.
I can't hear you. Oh, I said it last week.
You said it last class.
oh yeah.
Yes.
That's the one that's both like,
It's not personal.
because like, because I just thought, it's gonna be one over the thing, right? But then I checked the game, and it's by inversing the original expression. Yeah, and I was like, hey, it's not A working out right here. And yeah, I just decided to, instead of like putting one over, I just read the whole thing expression. I think think we went over
Did you make
once
this meme yourself, or did you find this one?
with words in general.
No, actually, I didn't even look for this one. There's a few people who know my feelings about Pi Day, so I had a couple people send that one to me. So I figured it was fate. It needed to go up. Judah.
That new pencil sharpener is boss. Man, that is nice.
Well,
That's a good
if you're excited about a pencil sharpener,
I get excited
let's
over
begin
wax.
rolling.
That is a game changer. That is a great investment.
All right, guys, our bells are turned off here, so we need to move forward. I want to limit how much homework you guys have, but of course it's going to depend on how quickly we get started here. So our lesson today is going to be very similar in structure to what we did last time, where I'm going to give you a small piece of notes. It's really an extension of the DISC method that we did last time. We're going to do those 4 questions together. Then I've got one Khan Academy assignment where I want you to practice and get a little bit of practice under your belt on that question type. And then I'm going to ask you to go back and spend some more time on an assignment from last week. One that I did not ask you to do for homework because you had a test to study for and I didn't give you more class time. So I'm trying to give you more class time today. So pretty similar to what we did last time, just different notes, different assignment to tie up the loose ends on. Okay, so last time we talked about the DISC method, which is where we took a bunch of circles, added up an infinite number of them with integration, and we were able to find the volume of a 3-dimensional shape. Well, we're going to do basically the same thing today with one extra piece to it. So before I tell you what's different and how we're going to handle it off different, we'll just pretend like this is DISC method and not washer method for just a second. So it's still going to help if we have a visual of what this stuff looks like. So give yourself a decent looking sketch. And if you draw them all, there's going to be a region that is trapped in here, trapped in all of those lines, a 2-dimensional area. David. Okay, so if we're going to spin this 2-dimensional area around the y-axis, one thing that we talked about, the parts that should be pretty quick, is it should be dy, and you should be looking at y values. So it goes up to 0, and the area starts down here as far down as -6. You remember that part? Okay, and then since we were using circles, what did we always integrate? Pi r squared. Now, unfortunately, the pictures are going to be even harder to work with this time, but imagine taking this point, and if I spin this around the y-axis, here's kind of the cross-sectional circle. If I take a point maybe right here and spin it around the y-axis, and maybe right here. So we did that with a couple of the cross sections so that we can visualize the radius, and it looks like the radius changes. It's not just a number, but this length, and this length, they all have something in common. What can I call that? Right, those are all x on this equation. So if we solve this for x, We don't want to say x squared because we don't want an x here. If this is dy, this stuff needs to be in terms of y. Okay, you guys okay with that? All right, now here's the part that's different. Now, and it's a little bit hard to kind of see what's different because it makes the picture gets really complicated. So, do you see how if I spin this around the y-axis, do you see how there's this gap in area right here?
Yes.
Well, if there's a gap in area, when I spin this around, do you understand that that's going to create a gap in volume? There's going to be like an open cylinder all the way through. Well, that stuff's not filled up, so that should not be part of our final volume. So what we need to do is go back and subtract it away. So it's like doing the dis method twice. Pi r squared. But what is the radius of each of those? Very good. It's always 1. But this time it's always 1. So it helps to draw in a couple of them, but that is always 1. So you may not see the connection, but the logic behind this is very similar to what we did with the area between two curves. We found the area under a curve. That would be like this. This is the volume of a shape. And then we subtracted away the area that we didn't want to get the area we did want. So this gives us too much volume, and we're really just coming back and subtracting how much volume is missing out of it. So if you can do dis method, it's just like doing 2 dis methods at once, but you're having to subtract those away. Now, it's fine to write it like this, but over time you probably want to do this instead. Both of these have a pi. Both of them are -6 to 0. Both of them are dy. And you can just combine this into one integral like this. In fact, when this shows up on FRQs, which is almost always on the AP exam, there's usually a point assigned just for this step. And even though I'm going to continue to phrase the other questions like this as well, ultimately what ends up happening in all of these questions, what will help you know that'll be there, dx dy may change, the limits of integration may change, but it's always the big radius minus the small radius, and of course pi, because pi r squared. This was our big radius, this was our small radius. Now again, I'll do my best with the pictures for you guys to see this, but do y'all know what a washer is?
Yeah.
Okay. So the picture up above, I tried to get you a good clean printout of what you have. So this is like this outside. This is what we did last time. If this was completely full, that's the dis method. But then if you've got some volume missing, like all this is supposed to be empty, you see how each little cross section is a little washer. So it's really knowing the dis method and then an application of subtraction. Okay, so there's one more that asks you to revolve around the y-axis. So I would like you to try this one before we discuss it together, and then we'll do the same thing with x-axis, and then we can move on for you to try in contact. Okay. Did y'all get the same little small sliver of area? Try to rotate. So again, you guys know I'm a big fan of pictures, but with this tiny little area and trying to imagine revolving it around the y-axis, your picture's probably nowhere near looking like a three-dimensional picture. So there's certain things that are certainly helpful to make this go a little bit quicker. I'm going to just combine these two together. I know it's pi big R squared minus little r squared. The y values, this was dy because we were revolving around the y-axis. Looks like it starts at 6 up to 9. Is that the limits of integration you got?
I got 2.
Oh, that's, yeah, my picture is terrible. Sorry. So 2, this should be 1, 2, 3, 4, should be more like here. This is where I said that if you put a good amount of effort into your picture, it usually pays off.
Is there a way to like check that exactly for us to find where that hits?
Yeah, what you're really doing is you're trying to figure out when this red line is in the same place and same time as my parabola. So you could really set these two equal to each other. Well, that's the x value. But you could plug this in, and then 2 squared would give you 4. Should be 4. And then up here, when y is 9, so this would be when the purple line hits the parabola. So if I plug this in here, x squared equals 9 when x equals 3. But we would want the y value though. So if you're careful about setting certain things equal to each other, you can solve it algebraically. Okay, so the big circle, again, I'm trying to think of it as big radius minus small radius, especially since they look for that in the scoring of FRQs. So if I try to rotate this shape, the big radius is going to go all the way to this edge, whether it's up here or down here. That radius length is always x to this function. So x is equal to the square root of y. The big radius was square root of y.
Why is it not plus or minus?
It technically is, but whether you do, you're going to square it anyway, so it doesn't matter in that case. And also when you say radius, we really mean like what's the length of radius, and lengths can't be negative.
Yeah.
So, okay, and then the small radius would be from here, the inside part, and again, my picture's not the best, but it looks like that would always be the same size if I try to rotate the inside of this area, because all of this is flush. All of this is at the same level. So when you rotate it, it's always going to go as far, and it looks like that length is always what? 2. Very good. From here to here is 2, because I know this is x equals 2. So similar to the disk method, there's part of this that should be pretty easy and quick, but the big radius and small radius you need to slow yourself down on. That's easy to overlook. Yeah.
So why is that? So it's the x value of 2, but does it really matter it being the derivative of y with respect to y? Although it's an x value of 2.
Well, we're thinking about the length of this radius. I don't really care anything about y at that point.
Right, I mean, don't you have to when you make it, when you're deriving y?
I mean, if it was like, if we were rotating around the x-axis, my cross sections would look something like this, so my radius would be some other number. But
Okay, so you just go plainly as what the value of that is.
well, for this particular question, we knew that this length was always 2, and when you rotate it, that would be how big that inner circle would be.
Okay.
So it doesn't change. Sometimes you've got something in terms of x or y that changes over time. If you've got some curvature, sometimes you could just have a numerical. This was always the same. My highlighter doesn't work in there anymore. But this region bounded by all those it was flat here, so when you rotate this, all the cross sections were the same size. Other questions that you can think of? Now again, my pictures are terrible, but sometimes it's a good idea to actually try to draw in one washer. It'll help you see. I gotta erase this. This is bugging me too much. Okay, here was the area. So here's the there's the outer part of the washer, and then here's the inner part of the washer. Sometimes just looking at one washer can help you see the big radius, and as it changes because this curves, and then the small radius was always the same because this was straight up and down. Okay, so now let's look what happens if we do around the x-axis. I think x-axis is a little bit easier, but honestly it's mostly the same stuff. Before I do anything, I know it's going to be pi. I'm going to integrate dx, and I'm going to want it in the structure of big R minus small r. Unless it's this method. This method you don't need to subtract anything because it's all filled in. But to figure out what these limits of integrations are, and to figure out how big the big R is and how small the small r is, my picture gives me something, at least a leg to stand on. So So here's our little triangular area. This is the area that we're going to rotate, but this time we're doing it around the x-axis. This is how it's different than the last two questions. So again, the bigger your picture is, I think the easier it is for you guys to see this, but even though I tried to plan ahead, I didn't do a great job. So it looks like if I just go straight here in the middle and try to show one good cross section, the outer part is going to look like this.
You're not going to be subtracting, right? Since it's touching at the x-axis, there's no
but it's only touching.
space.
It's only touching right at this point.
Oh, so
so
it's-
when you flip this gap in area is going to create a gap in volume right there. So sometimes you can do this too. Obviously this doesn't make it look very three-dimensional, but it's going to kind of look like this when you spin it in 3 dimensions. So how big do you think the big R is going to be?
Why?
To me, it looks like if you start back here and all of this is flat, whether you do a cross section way back here or way over here, to me it looks like the circles, the cross sections are always going to be the same size, and the radius is going to be this length, which is 3. And I'll try to erase that so that there's less stuff going on. Now, when you guys move over to the Khan Academy in a minute, I think they do pictures of everything for you, so that should help a little bit. Yes?
Why is it not the Y value?
Because the Y value is this. Is this the big circle? That's the big circle.
Right, but that's saying the same the entire time. The big circle is, and isn't that just the Y value, the radius of that is? Like Y is equal to 3x minus 9, is that not that?
But it's, you don't need a Y in your answer because it's always the same thing. Whether you draw it here, the radius is 3, draw it in the middle, the radius is 3, draw it at the end, the radius is 3. We don't want any variables in that. It's always 3.
Okay. Because it's constant, okay.
Yes, it's constant. The radius of the big circle is constant in this question. But the radius of the small circle can change. So notice Like here, it's basically non-existent, but this gap, an area which creates a gap in volume, changes. So since it changes, that tells me I'm going to have an x or y, x for this question. So we got to think of a way to describe this in terms of x. So the distance from the x-axis to the function, we normally call that what? What's this radius? Y. But I don't want to call it y because this is dx. So instead of calling it y, we could call it right. What y is equal to when it hits that function that I'm drawing it to. Yeah.
So do they switch depending on if it's x-axis or y-axis, or is
It can.
just this problem?
You can't simplify it that way. It just depends on the functions. It depends on where your area is. It depends on if you're rotating it around the x-axis, the y-axis. There's not like some rules that you can just say, if this, well, you could, but there would probably be like a dozen of them. It's better to just try to get it from the pictures.
Are the bounds 32?
Oh, yeah, and the bounds are, they need to be x values, so not 3 to 2, but 2 to 3. Smaller to bigger. 2 to 3. Okay, so again, as careful as I'm trying to make my picture be, and as much time as I'm spending on just the radius, you guys can see that's like 90% of my thought process. That's really the hardest part. But I want you to try it one more time. Draw a picture. Try to learn from my mistakes. Make your picture fairly big. The bigger the area is, the better your little circles are going to look like, the more likely you are going to get the correct big radius and smaller radius. Your lack of pictures can certainly make the questions harder than they need to be. Okay, let me kind of start this one off, and I'm going to kind of go in maybe not the most direct way, but I think it might help you guys see what you need to do here. So the parts that you should be struggle with is rotating it around the x-axis means dx. So you should be looking at x values, so 1 to 2. If you're having a hard time finding those radius, what you can do is pretend like it goes all the way to the x-axis for just a second, although it really doesn't. And then what you're doing is the dis method. You could take this point rotate that point around the x-axis and get you a big cross-section circle. Maybe down here, take that point and swing it around the x-axis. And then you can see your big radius is this is 4.
The big radius.
Well, all of these are the big radius. All of these are the outside radius. By big, I don't mean the biggest one that I drew. I mean the biggest one when you're thinking about a washer. So what does this length, and this length all have in common? So this is like pi r squared. Well, not y, but x squared. Right? But then you have to realize, well, wait a second. I pretended like this went all the way to the x-axis so that I could lean on what I learned last time. There's really this piece right here that is going to be an open circle. So I have to subtract away all of its volume. So minus integrating 1 to 2 of pi r squared. And what is that radius? Always 1. Or I saw on the Khan Academy, if you click the more help when you miss a question, they do a very good job of showing the washer. So they like show the outside cross section and the inside cross section. So then that kind of helps you visualize. All the way up to here was the radius, which was x squared, and all the way in here was the small radius, just 1. So I think that visual is very good. But here's the washer and the washer method. Now there is also something called the shell method, but you guys don't have to learn the shell method for AP. But if you're interested in that, just a different method, not easier, but just different. Okay, so for scratch paper, if you would please number your scratch paper is 106. So I've got just one of these. Same as last time, feel free to do the integration in the calculator. We can practice integrating again another day, but really just practice setting those up. And the first time you miss one, if you miss one, click the get more help, look at their cross section, see their washer, and see if that helps you see like how you picked out the wrong big R or small r. And then if you're still struggling, then you need to get me or one of your neighbors to help you. So do that first. I'm hoping that doesn't take too long, but if it takes you several tries, then that's okay. This is important stuff.
This happened was sat on this case and I have no idea where to find the big circle, where the small circle.
May I use a mini sticker? You can try it. It wasn't working a minute ago, but
yeah, I think maybe
still no?
Yeah.
All the one.
You want to take it? In the basket.
Honestly, I can see this.
That's for Kentucky with his dad.
Oh, it's the Kentucky
He already knows he's going. He gets to go to the Mr. Johnson, do you remember Mason Lowry?
Huh?
Do you remember Mason Lowry? In the pre-cap? Remember how he'd always tap his foot during the tests?
Yeah.
Who? Mason Lowry during our
Couple
tests.
times.
He'd be on like pre-workout and he'd be like tapping his foot like this in the middle of it.
We gotta do couple foot tappers in this classroom.
What?
I mean, I get it, but you can like, get a Q-tip or something. Like you can find quiet ways to.
And it wasn't necessarily tapping, it was the shoelaces clanging it against the desk.
Oh, was it? I don't remember that. Did I tell him to stop?
I feel like you did at one point. Because it just got so loud that our whole class was like looking at each other in the middle of the test. He fell asleep during our AP push exam and he was snoring.
He's a force to be reckoned with.
Yeah. Mason like.
Oh, Mason, okay.
He's probably tired from. Doesn't he work out all the time?
Yeah, that's pre-workout. Pretty good.
I mean, I don't think your AP test should count as pre-workout, but.
His BBQ was about working out.
No way.
Yeah, he wrote his. He
Oh,
didn't pass
no,
the
I
exam,
remember
but
that. I remember him telling me that.
It was probably a sick BBQ.
I remember he was like, man, if only this was physical science.
Also, I think every question on here asks for your answer in terms of pi. So if you don't remember that from last time, you will miss it until you ask what you're supposed to do. Isn't Mason doing calculus this year?
Yes.
Is he?
Yes.
Which one? Is he in the Netherlands?
He is. He lives down the street.
So what you're saying is there's a chance you're all gonna be doing your AP calculus test. And
Oh
he's
gosh.
he's
Oh
either
wait,
gonna
no,
be
it's guaranteed because we're always in the same room.
yeah, he'll either be tapping or snoring.
Yeah.
I don't know.
So like, I don't know, so like, exactly like, what?
Well, this would be the radius of the smaller circle, and this would be the radius of the smaller circle, and this would be the radius of the smaller circle. So it looks like it's always 3
So.
for that example.
So I got 2.
How do you do it immediately?
Okay.
How do you get when you have the answer in fractions and not decimal?
How do I get the answer in the fraction?
Yeah.
All right, well, do the integration, get a decimal, change that to a fraction. How do you do that? Math, enter. First option says change to a fraction, enter. And then your answer needs to be in terms of pi, so that times pi. Let's start this.
Oh, no way.
Mr. Townsend?
Hold on.
Yeah.
That's cool. Isn't that huge?
Furman's got this is why is he root of X? Whoa. So what are we trying to how are we trying to do that thing? Oh, okay, so y cubed is equal to x, alright. So what's wrong with that?
Somehow the 8
Yeah, if you rotate this around.
This one?
The y-axis.
Yeah. West Virginia's down by 3 with 50 seconds.
To me, that would be, if you're going around the.
I don't really wait towards like the final four to submit my
So you're from here to here would be
my
the
March
small
Madness.
Oh, okay. Gotcha.
I've won almost every year.
Oh, yeah.
You didn't win one?
I would think this.
Yeah.
Big-
Well, you still have a
big
1.6.
circles and then here, big circles will have a radius.
So everyone else is the same thing.
Big circle radius of eight, small circle radius of 1.
Was it last year March Madness like
Small here, bigger here.
They took a lot of
I'd be able to remember last year.
I remember last year.
Well, no, I just feel like last year it was like, gosh, like,
I just remember
like 2%
Oh, no, yeah.
Was it because of the fighting clip? Because of St. Peter's.
Jerks.
I love Douglas.
Oh, Jimmy Pepper. Yeah, this is interesting.
You're putting that in like the bounds, you're putting the y cubes in for your big
Oh
R.
my God.
And I think it's your small R.
Sure.
Because you're rotating this around the y axis. So this little bit.
I wanna work it out.
So this length is the small radius. The big radius is gonna be this length, 8.
Work it out.
You pay.
Again, I can try to help, and I can try to help y'all see the big radius and small radius. But when you miss one, if you click to get more help, it's got a nice picture where it draws the washer on the actual graph, and it makes it a lot easier to see. I think seeing a couple of those would, maybe in the long run, actually speed you up.
This is the first one. This is the second.
Yeah, so you're talking, this is your bottom.
Yeah,
No, this is your big, so it's big.
that's 2 squares. So the first one's 2.
See, I didn't get it because I couldn't do it. I didn't know
This
about
one's
the
square
square.
1.
Like, I could convert you guys.
Does math like right? Math's in your
Whatever your highest and lowest.
X-axis is hang around. Mr. Swenson?
Uh-huh.
The larger radius in this case would be 3. It's,
Are you rotating around the y?
oh, it's the y-axis.
Yeah,
That'll make-
so
that'll
it's gonna
change
be
things.
4. That's a 4.
Oh, good. Yeah, it's gonna go proportionally. This case, this line is what's gonna subtract.
Right, so that's gonna be
In terms of the Maryland one, or no? Yeah.
And you want it
Or
in terms of y,
y.
if it's the y.
Actually, yes.
She said to call if you have any questions.
Okay.
This is 1/3 minus 4. This is rotated.
That much. There's no area in that. But it's like, maybe it's like your rifles. But we don't know if this
So that would be.
So this is your this is your.
Oh, are you not waving?
What about Miss Hilarious?
I love mirror class. Okay, I just want to make sure that I'm understanding which one's the big one and which one's the little one. Okay, so it's rotated about the x-axis, so it's going this way. So my big one.
X-axis?
Sorry, y. So it's
Okay.
going this way.
So your big radius would be
4. Yeah. And then my tiny one would be this one, but I have to change this to that.
in terms of lines. Yeah. Yeah.
Alright.
Thank you.
Jeff.
Out of curiosity,
Did you get this right?
We're getting.
Yippee! No, you gotta be like,
Yay!
What did I say? Oh.
Hooray!
Hooray!
Hi.
That's gotta be like, and the fist pump, and the fist pump.
After a while, y'all put so much thought into the radius length.
You get it.
Don't
Let me
think
get
about
that
the
right.
pilot.
If I get this right, you're gonna get the hooray.
I mean, not right now, that probably wouldn't be the most common mistake, but on a test, it would be a very common mistake, just forgetting to put the sign.
So the big one is this one.
What is it? No, I know the answer.
Oh.
Extra one. You already did it. It should be.
Sine regular to y.
I'm sorry. I told you.
Yeah. Wow. So then
Should have listened.
I think it's actually, how about we were wrong?
It's like 64 pi. Because you didn't multiply in the pi. Okay, once you leave pi.
Oh my gosh. Oh my gosh. Oh my gosh. Oh my gosh.
No way. No way.
Oh my gosh. Oh my god.
That's like the first time hearing Gonzaga, you know, I'm like, who is Gonzaga?
That's actually.
But that was when they won, yeah. X-axis.
Determined to win. I was Maryland.
You got rid of it all.
I don't think they're gonna win.
Our class is Kansas.
No, Arkansas is good.
Oh, okay. That's an unpopular opinion.
Upset Kansas first round.
Except by Arkansas.
And then usually they give up by this time.
Yeah. Comes second to Abbott.
You pick some.
Not everyone who made it to the Final Four, that's a big deal.
This is number 1
Okay, big one.
Okay, I think I messed this up. Alright, one shot.
No, I'm still on. We're 3 and 4 in a good way.
Mr. Johnson.
We're gonna have to wait and helping her.
That's huge.
That's huge. You love to see it.
Still have
I don't. I don't.
Jim.
It's always been. Fair enough, like.
Now it's telling her, can you pick first? And goes, no, Virginia's gonna learn.
But some of them are just like, yes.
This is a freshman.
The way she.
I was like, no way you come on King.
This would be sad.
Kiss the meeting. She has a couple of them.
She left like 12.
Two. I'm so
We're not as concerned as others.
They weren't all insults. There was like one that was an insult. I think it was only one.
What was it?
Good use of evidence here.
How's that insult?
No, it looked like the other one was.
Why would we lie?
Yeah, they're like.
Sorry.
Okay. I feel like I'm Same, honestly, I'll be I look crazy.
Hey, guess what?
Hooray!
Did you get 100, Jeff?
Yeah, I got it. That made me so happy.
Okay, well, I don't.
Jets.
Yeah.
Did you get this problem?
I actually got 100.
So,
Big one.
Which one is the big grade?
no, that's okay. Our big one is the big one. The little one's small.
Oh, shoot. Tired of
I'm a little tired.
carrying calculus on your back. Yeah.
All programs working in it.
One or two.
So this actually has a little bit of a round. Trying to say 0.4.
Wait, I know the answer.
0.4 decimal down.
I got too much to go on.
I had that one. The answer is I put it down. I trust me. I put it in. The answer is
0.4. Okay, you gotta be clear here, guys. 0.4. Dude, hey, I don't want you pulling on my leg here. You're gonna have to wait in line.
I'm all good.
I got it. Hooray.
For this one, would you just subtract both of these since it's just this part? So would you
Utah State's over.
This is all but I picked up the win, so I better win.
Well, then your outer circle isn't gonna go all the way over here. It's gonna go like this.
Oh.
So this would be your big radius, this would be your small radius.
Missouri and Utah State.
Well, I got like
It just started.
Oh, okay, you got the same one you did. So,
I ain't doing homework.
when you calculate your decimal thing, if the computation is too complicated, sometimes it has a tiny bit of rounding error.
Oh.
It's trying to say 0.4.
Oh.
So if you change 0.4 to a fraction, let's do this. So your answer should be 2/5. You're next.
Yeah, I'm confused where you're getting most of these numbers. Specifically where you
Wait,
I'm
Jen.
confused where you're getting them out.
Come here.
I would not use conversion. That's personally. But it shows you that way.
I mean, the bounds is
This is,
zero.
look at what she did.
that would have been
It's like 0.6637. He said that's a rounding error, so if that happens, just
Well, the bounds you're gonna have to set these two next to each other.
Is it 1.3, I guess?
I mean, you can, but it's not gonna get you too close to 35. That's gonna give you a decimal, that'll be pretty close, but it won't be exact.
Harrison, no, Harrison. Okay.
Yeah,
So with this, so we're sitting, me, Crew, and Joe are sitting in Thompson Solution in my car.
Oh, is that what's on this?
That's just
So
negative 21.
Crew was like, oh, I see Garrett's car, grabs the solution, and starts spraying all over Garrett's car. Crew was like,
Hey, Harrison, that shirt's pretty pimp, dude.
Thanks, man. You're pretty pimp too.
Hey, thanks. Wait, that's Pablo Escobar, right?
Yeah.
Yeah.
Oh yeah, is that when he traveled to the White House?
Huh?
Is that when he went to the White House?
Yeah, he was the most wanted man in America.
Yeah.
For this picture.
Is this one or negative one?
It's real. Like he actually went there.
You gotta admit, that's baller.
Like I always envision like 30 people at this time in the White House being like,
Yeah.
you know what I mean? And he's like out front, you know.
Yep, she made us sing it actually. Actually, she made Edgar Torres sing it.
Okay, well, that's where the bounce comes from.
This equation?
You gotta.
Finish solving that, and you should get the bounce,
So, buddy?
and then you call me back.
Yeah.
Okay.
So what I do is kind of understand. So what I start at the area.
You may think you know the answer, but do not. 2 squared is not always 4.
The answer is like your balance.
We got this is going to be your big circle. So this would be your big radius. This would be your small circle.
Yes.
So that would be your small radius.
So actually
That's
We'll just be taking this whole area and trying to spin it 3-dimensionally. So this blue is going to be the outside of your whole shape. So this is going to make it your big R. This is going to be the empty space.
The silly spray.
This is going to be the small R.
Oh, that makes sense.
But it totally wasn't Crew though. Tell him that, Harrison. It totally wasn't Crew. He doesn't need to think that it was Crew.
You done with the other thing?
The concavity.
There's something after that.
That's not supposed to be.
That's equivalent to the square root of 5.
Yeah, you're doing everything.
Okay, yeah.
The middle over there.
Oh, were you talking to Jeff?
Yeah, he might have been. So, we'll never
What's
know.
the next step with these?
I don't know. I don't know.
What is that?
Well, you're telling me.
Oh, you just let it sit and unfold it, I guess.
I don't
My
know.
next step is to be annoyed.
I don't know. I just work here.
Like throw it away.
Huh? What is it?
My chemistry project. You're done? Tie-dye t-shirt.
Yeah.
Hey,
Is it two? It's
Hey,
double XL.
if you don't want, I'll take it.
No, I'll check your answers. I really.
Check your answers online.
Okay.
It sounds like Mr. Townsend's house was overtaken by a paradise, you might know more about it.
That'd be like a.
I don't know. Put it in a bucket and put it outside or something. I don't know.
Yeah.
They didn't tell you how to finish it?
Well-
What's the point of doing it if they're not going to tell you how to finish it?
I bet that I think he was saying that there's a lot of resources online for that.
Oh.
That is what.
Maybe.
Make up the balance.
Okay. So you're going to integrate area. Use the area formulas from the front page. Catch a picture to figure out your baseline.
Sketch a picture.
This is really
Is square the same as rectangle?
Where is a square the same thing as a rectangle?
No, it's not. But then where do I find the area? It's on the front page.
Does it say circle or semicircle?
It doesn't say either. It says rectangle.
Okay, well there's a couple rectangle ones on the front page. Does it say
Do I have to solve it, or I just leave it?
Well, you should at least throw it in the calculator and make sure you get the same answer.
Square cannot be
I mean, unless she sets her, this is not my solution. She always sets hers up different than I do. So that's where I get the same right, same button. So a lot of times, like instead of integrating -5 to 5, she'll integrate just 5 to 0 to 5 and then double her answer because of symmetry.
Oh, I saw that on some of the stuff, and I was like,
If you have to do the integration by hand, it's nice sometimes because it's nice to plug in 0 and make a lot of stuff go away.
Yeah.
But the problem is if it's not really symmetrical and you make that assumption, then you
Oh, this one, I'm on this one right now.
Oh, it's page 102.
the Paladins.
Or it's number 1.
Running out over here?
For a little bit.
I just said that backwards.
Anything I can help with? Do you know what you?
Yeah, I watched the video for the day I missed last night.
Good.
So, and I got done with the Khan Academy really fast because it must be quick.
Okay, good. What about this one from last week though?
Yeah, that's what I'm getting to.
I gotta go to.
But yeah, that looks like the right thing.
Okay, let me put in a few of these grades and I'll come back around and help some more.
Yeah, why do you have clothes? Why do you guys clothes? So where's my name? Huh? Where's my name? Bro, whenever you guys have class. Well, you're tough. Like, I'll like 2 to 3. I'm not Just tell me. Not as good as Chase, so it's not bad. We'll let Chase and Chase.
Are you guys doing like an INRAC course next year?
Yep.
Harrison,
You are?
Jeff.
Is it, do we get a new email or something?
I think so.
You do.
You should have gotten it should right there. Are you good?
I am. I just can't remember what the email was.
So if you should have, or is this your first time?
Yeah.
Okay. Then they should have sent you an email that looks like.
Oh my god. I'm actually in a concern right now. I'm telling you that there will be an email from probably Deanna Norris.
Yeah.
And she'll say like, hey, we want you to know you're gonna be an NWAC or whatever. Here are your next steps, and then you go through that, and then you have to fill out a thing that's like, here's all the things that I'm doing, and here's why I want to do them. And it's not that hard at all. And then you wait for a while.
But did you get like a new email?
So there'll be this email and it'll have your.
And they will give you an email account for Microsoft Outlook.
The answer to that one is 32.
That's not until you log in or create
Yeah,
a new
that's not
account.
until you're like fully enrolled and everything.
Okay.
Yes, it is.
Because I got the thing was
You should have gotten an email from.
What class are you taking?
What? I'm taking medical terminology and Comp 2.
Are you going into medical?
I want to go pre-med. Yes.
There should be an email from this person.
Okay.
And it should help this infographic. And that should-
Because that infographic
Yeah.
once we should be is NWAC.edu. What is your
So you should,
username?
yeah, you should have gotten an email that looks like, I forwarded it to myself because you know I found an email and everything. But you should
Oh,
get-
that?
Yeah, and it's this one.
At edu. NWAC.edu. Cool.
You know what?
That must be. Thank
No, of course.
Must have been
Oh, I did that. So
It's gonna be great.
Yeah, I think I have a. Okay, so
the bound is one
With like Noah and then this is If the base is 3y, so it's
The big one will be, so is this around the y or the x?
Oh, it's gonna be.
So around the
Okay,
x.
it's
So
gonna be.
it's gonna
It's
be
going to
like
be.
a third of x squared is
One.
1 squared.
Oh, here we go.
And then you plug it over that in without the pi, and then you just do it.
Yeah.
Yeah.
So I would say all of this would be the base.
How come this can't?
All of this.
I have this.
That's where your rectangle is on your piece of paper. Now technically the rectangle.
Yay!
Yeah, okay. 3 dimensions. I got it all this way. That's the base. This way here's 2. I've got both. Okay. You know, someone twice that one. That's also what I read that. I'm not that, so that's gonna make the height of the word. 4y. So then the area, which is what you want to integrate, the integration area is 8y squared.
Oh my god.
I have not. 8 times y
Okay.
is.
You're staggered. Oh, I did it.
That's.
She just finished. I just finished it. So you can have this, but I don't know what it
That's how I.
meant last week. I did know what it meant last week. I think it was gonna be drawing.
Yeah.
What's Why do you say that? On his,
Is that a circle? Circle with radius 5?
Yes, sir.
You're not even looking at it.
No, I didn't.
And it's a semicircle. So there's a few semicircles.
Okay.
Are you checking out or what?
Yeah.
Okay.
Well, I really need to look at it. Check it.
Make sure you get checked out.
And I'll help you.
So, to me, when I integrate these, I'm gonna send this to you. I just always integrate area. And I know a semicircle is 1/2 pi r squared. And I can see the r is 2y, and then you just change y to x.
Okay.
If you want to memorize that formula on the front page, I don't do it that way. It's like 1/8 pi.
That's funny, because on number 1, it says 1/4.
Will this give the radius of the circle?
5 piece base squared.
Or sorry, volume.
Oh, yeah.
So, yeah. So you see like if you squared this 2, you get a 4.
Yes, sir.
Well, actually, no, never mind.
Doesn't matter.
Okay, I don't know how to show that they're the same in that direction. But if I do a circle, or a semicircle,
I mean, it makes sense. Like if a circle is pi r squared, then the semicircle should be
So many words.
Yeah.
So
okay,
bad.
so in terms of r, a semicircle is 1/2 pi r squared, half of a
Yes.
circle. If you think of it in terms of all of this diameter, but we're gonna call it base because all of this would be the base. All of that. Okay. Okay.
It's
If
not
we think of
2y.
it,
What is this?
you would get 1/2 pi and what is r in this sense?
It'll be easier to get that.
2r, so it's just
Or
2r.
you can get it better plus. Sure.
Okay,
I think
so
that would be harder.
except the other way though. If I do 1/2 pi, I don't want to say r squared. R, how does r compare to b?
R is 1/2 b.
Okay, so another way to say that is b is
2r.
1/2 r.
Wait, why? Wouldn't it be the other way around? Because 2r is b, so.
Correct.
So it's just r. right?
Okay, hold on. Give me 30 seconds. This is.
Oh, is this for the semicircles?
Yeah.
We're finding out there's like the 1/8.
Yeah.
Yeah, where the 1/8 is. Yeah.
Oh yeah, I understand.
Okay, so if 2 R's is a B, then 1 R is B over 2.
Yeah.
So in place of R, you can put B over 2. Then when you square this, you get a fourth times a half. That's where the 8 comes in. But
I'm only asking because Ms. Bonilla called me to tell you that.
seems okay.
Yeah. She did.
She left, yeah.
Did they call you in here?
I don't know, it didn't go off, but it seems okay.
Oh, thank you. Hold on, how was the square, the 1/4 square? Oh, so
Did you bid?
1/2 times 1/2 is a fourth.
Yes, Missouri's a
Times
good.
this 1/2 makes it an 8. So if you want to call all of this your base, you can use that formula I gave you on the front page.
okay, but then
But
otherwise.
that's another formula to learn. Otherwise, just do 1/2 pi r squared and think about what your r is.
But that's more thinking to do, so I like to do
You like which one better?
the where it usually gives us 1/8.
I like 1/2 the power squared.
Yeah, but you
That
gotta,
makes sense.
you gotta memorize that 1/8 is pi base squared.
But that's not that hard to memorize.
No, but 1/2 pi
It's
r squared makes
easier
no
to
sense.
memorize that versus like I really gotta think about, oh my gosh, what's my
Well, you're still gonna have to think about how big the base is for this formula. So I don't feel like finding the base length as hard as finding the radius length. You already know a circle is pi r squared, so a semicircle is gonna be half of that.
Wait, I just
planning on like 8.
I just realized. When you do this so when you do this, when you do the 1/8 pi b squared, you use the base, not the radius. When you use 1/2 pi r squared, you use the radius. Yeah, do 1/2 pi r squared makes sense.
I mean, that's why I go ahead and give you this one, but you can either memorize this for this one question type and it'll work, or you can just use what you know about semicircles as half of the area of a circle, find the radius, and then it's one less formula to memorize. But
Plus, when you do a circle, you already do the radius. So I feel like doing a semicircle, I don't know, just easier.
well, I guess some people think the other one's easier, so.
I'm a one guy. I'm an 8. I'm not a half, I'm an 8.
Big comment to you finish with that one.
Yeah.
Figure out what you needed after that.
Yeah.
Yes.
So you don't wanna miss this one.
He's like, tell me something else. Tell me something. Tell me something.
So this, your squares need to be, -5 to 5, and then add r squared, or, sorry, base squared, right?
Yeah.
Does that give me the correct volume?
And what's the base?
Base,
They have it. Not
right?
Not that, no, you're drawing it, but that's not it.
And I heard Riley, on the pasture.
Base of this.
Or Riley or Riley. Whatever name. Whatever name.
Well, I don't know how you're gonna measure.
Newer
this.
one?
This one's-
Yeah. The Chromebook charger.
Or Boris.
That's what I think.
What's this one?
But yeah, I heard she on
On in which way?
by
Because of you, so.
This one's wide. So your base is
But they,
Oh, are you talking about-
because I was passed out. I was.
This is where your, no, I was where.
Well, no, I wasn't.
You weren't. No. You stayed up. I thought you stayed up.
So
Yeah,
your
I was
base
trying to
is
make
too
sure
wide.
nobody blew up.
So then you just replace y with
Yeah.
what? Or what is equal to?
Big right or?
No, Harrison, I was.
I just like to have everything on one page, so I don't, it's too wide, yeah. So I need to,
But they didn't.
I get that the base is too wide, and then you set, so wait, can't I put
Yeah.
that?
No. because it's gonna get squared. You can put a 4 out there,
That's just so easily.
but why? That's not gonna make a question.
Square, right?
Look, it does it again. It does it again. Rah.
No.
Okay, but you need it in terms of
The
X.
dude dunking, the big number 30.
Hey,
Instead of Y, you need to put what Y is equal to.
Jeffrey, can I get a second opinion?
So you need this equation. You have a circle at the origin with radius of 5.
Wait, so if 2y equals x
Which one
times
is this?
x equals 1/2 x equals y.
No, I'm talking about this shape.
Uh-huh.
What's the equation of this?
X
No way you're gonna
minus 5.
Dude, that's.
No, it equals 5. It's x squared equals y squared, right?
X squared plus Y squared?
Yes.
At the origin?
Equals 5.
Okay, so we have
this way.
the big one.
You're so close.
So give me that, X squared plus Y squared equals 25. You can solve that for Y equals, and then plug it in there.
Oh,
Y. The big one is this 1/2. But it's really 2y. It's square root of 2y. It's square root of that.
It's almost like a valid number.
Okay, yeah, good point.
Why?
Yeah, no, put the
and I need to multiply that by 2, right?
You don't wanna. Don't you?
Because it's-
Yeah, you got 2 of them. Yeah, you got 2 Y's, so. So 2 times what Y is in terms of X.
You working hard, you working hard.
Oh, God.
Did you make it? Yeah, well, that number 30 can be busted twice. The dude is a dog. He doesn't.
For senior skip day.
Quick math.
He's carrying his hand. He's carrying his hand.
And he can shoot. Oh my
Go back
god.
up there.
No way. He's gonna do it.
This one?
All right, does anybody actually think Arkansas is going to beat Kansas?
I actually do. I actually do.
Well, I have a bracket of us winning the championship.
Just remember that.
I do it. Why? Because Arkansas can do it.
It's possible, but I wouldn't bet it.
We have the potential, yeah. Dude, have you noticed it's like every single SEC game, you get up and then at halftime when
I know our halftime is horrible. We have no offense in the paint. We're not aggressive.
something's going on in the locker room at halftime, like
Yeah.
You went to the U of A, right? Were you ever in the student sections of those games? No.
How about it?
I don't. Well, first off, you go. Everything's expensive. You have to deal with lines. It's crowded. Now, when I was a kid, I went to some good games, but like unless the games, like I don't want to just go to an average game. Like it's not worth the effort.
I only go.
And plus, I teach 0 hours, so like how often can I really go to a game?
I only go to one I go to minor league schools.
Like naturals?
Yeah, because they're just. I think they're more fun than major league games. And also, if you go on Fridays, they have
Now, one game do you know who Todd Day is?
What?
Todd Day. I went to the game where he broke the scoring record for the Razorbacks.
Oh.
So that was a crazy game. Like that place was. Yeah, it was. And then I went to another game where a guy like broke the most 3-pointers in the SEC. It was like 13 or something. He was just making everything. That was a really fun game to be at. But
during college, you never like not much. So don't you get free tickets as a student?
you can, but if it's a big game, you have to like camp out because they have limited number.
Yeah, it's not worth it. That's worth it.
Like some of those football games, like people camp out for like all weekend.
But if Lauren did that, she
This guy.
and her friend had like a one stroke waiting in line.
Yeah. Not worth it.
And like this one college,
I'm not
like
doing
they
that.
camped out for like 2 weeks prior to the game. I forgot where it was. But they started like a month before, like when other games were going on at the arena, they were camped out for like the game. I think it was like Duke and North Carolina or something.
Oh, I thought you were talking about for Hawkins.
No,
That makes no
no,
sense.
no, not for. It was a different college.
Duke North Carolina game, that makes sense.
Small here.
Yeah.
There was like other games going on. They're like, nope, we want to go to this game 2 weeks from now.
You gotta
And
do what
it's
you
while
gotta
they're at like these, while they're at college games, so they're like doing their homework and it's like the camping tent.
You gotta do what you gotta
I'm really good.
I'm not ibuprofen.
I'm a little late, so
We'll be cutting it close.
What do you like, paint?
Yeah.
Like, it doesn't start moving until like 30 minutes in.
I can't visualize it for you more.
No, usually
Like,
takes
this
more.
is,
So usually like
oh.
an hour and a half
I'll show you.
before I run.
The washer's right here. Just enjoy the paint washer.
Text them in the description.
Auburn's better.
Auburn's
Yeah, yeah.
Are you looking for it? Yeah, I know what happens.
How is it? You cut it for 30.
What's his name?
Do you know that there are bees that
Have you had?
I just want to do 30%, let's go.
I saw this thing, this guy was making fun of like, if you don't have that. Oh, that's like the honey they make.
Yes, no, that's the hive that they make.
Yeah, no.
They don't overproduce honey.
I'm sorry, that's understandable.
They make honey
One time
from
we got attacked by a
Colton.
dog.
Think about it. It's the most insane thing.
That would be
They eat
gross.
roadkill.
That would be gross. So,
What did you do?
you know what's really dope? Like, Rangers know like,
I misunderstood it. Like, just didn't like go for like.
No, I know. There's like Appalachian wildlife. There are.
Dan's gonna win.
There are some babies that people get like a toxic flower and make honey from it, and then if you eat that honey, you go insane. Because of course you know, like bees will make honey with like hallucinogenic plants and stuff. They'll just be acid honey. I'm stressed for you. But like that, happy stories with them.
Yeah, no, I think way more.
So you just like.
Not like that.
You can get like anywhere maybe.
This motor's so fast.
I'm crying for you. There's nothing I can do because I know you're a better player.
It is impossible though. I already. You literally have like
A win in the
That's so exciting. I wish I
dramatic out of public. I've been getting hurt. Like, people be good. Like, it's just a concert assessment. Like, it's not even.
I don't wear. I love how.
Bye. Have a good break.
If I was